Okay, so we've just gone over relevance models and shown how they are related to Dirichlet mixtures, and that we can basically think of the problem in this fashion. Let's look at another way that we can sort of look at the overall problem of we want to better estimate the query, we want to expand it in an automatic fashion, so forth and so on. So put this another way, with the general title of how else to think about this problem. So I just showed that, we can look at it as we're making these mixtures of these language models and retaining some notion of the original query. All right. Well, let's take a look at it as follows. We can actually think of retrieval as some math that we do with matrices and vectors. And while we're not going to literally go and take the document and word matrix, so where we've got rows of the documents and columns of the words, and we're saying which words are present in which documents or what weights we have, we won't take that full literal matrix necessarily and do this. But we can look at some operations on that matrix and see retrieval in light of these matrix operations, and then we'll end up with something that gives us another set of insight into this whole overall notion of basically smoothing the query or better estimating the query, whatever we want to call it. So let's just take a look. A basic notion of retrieval would be as follows. We have some collection matrix, and we're going to multiply it by a query vector and get back out a set of results. And so let's look at this in more detail. So the collection matrix is a document by vocabulary, so D by V matrix. Basically, again, where we've got documents via the vocabulary. All right. We've got this matrix, and for example, an individual row of it is D sub I. And then what we're doing basically when we run a query against it, so we've got this query here as a vector, and effectively, for across each of these documents, so we've got this document, and when we multiply it by the query, that's a dot product, right? And so the results end up being, so these are our document scores. And so an individual cell of that vector element of it is basically, as I just said, the document I dot product with the vector Q. So dot product of the document vector and the query vector. Okay, so this is the basic notion of retrieval. So this is our documents by vocabulary matrix. Let me move vocabulary over it. So our document by our word matrix. This is our query, which is a V times 1 column vector. And our results end up being a D by 1 matrix of results, or again, another vector. So this is the basics of what we've been doing, right? Basically we're coming up with some way to have some weights on the documents. Weights were for each word in the document, some weight for the words base, that's our notion of our query, and we're doing all these dot products across all the documents to produce the document scores. That's what we've been doing basically all term long. So this is a formulation of the retrieval problem. Now, if we've got it in this form where we can talk about the matrix C, the query, and the results, how can we look and see relevance models in this? Because you're like, well, wait a minute. We've been doing language modeling. We've got probabilities for words in the documents. You haven't, yeah, I can see maybe we've got these dot products there, absolutely, but you haven't showed us how to do fast retrieval with the inverted index. Trust me, you can. There's some derivations, and then all of a sudden you get to do that. But yeah, at the core of all these techniques is this dot product between the documents and the query. All right, so we should be able to sort of see our relevance models in this somewhere, somehow. Let's go to that. Okay, so in this makeup, what is relevance models? In sort of an abstract form. So I gave you the form previously. Now let's sort of a little bit more on the hand wavy side of things, but it's still a reasonable way to understand what they're doing. The first step is we do, as I said, C times Q equals R to get the doc scores. All right, so these are our document scores in the results. R is results here, not relevant, okay? Then we can take the transpose of the collection matrix, multiply it by our document scores that we've computed, and we'll end up with a new query, Q prime. Okay, so we do this to get a new query. Basically a mix of all documents. So each document is represented by some vector. For every single word, it's got some weight to it. It's a mix of all documents weighted by R. So this will now give us, we're going through all these documents and we're going to weight them, and we're going to get back out a new set of weights, so to speak, for the query. And I'm not saying to literally take the document scores and multiply them and you'll get literally the new query to use. But essentially, this is the operations that are happening. Okay. And yes, we might need to modify what the scores are here before we actually multiply them here. And then we might need to change the final results, weight them somehow, proportional, whatever, to be able to have a good query to use again. But basically, we would have the idea we could go and now our third step is we can go ahead and we can run that query now back against the original matrix. And this is the final results. All right, so this is pretty cool because this is really what we're doing. So we are basically, we have a query and we get out a bunch of document scores. Then we can use those document scores to give us a new query, and we can use that query to give us new document scores. By the way, you could keep doing this back and forth, back and forth, back and forth. Absolutely. We do the way relevance models is that it says, oh, I'm going to stop after one iteration. Okay. So let's put this together. We want to do it in one fell swoop. We can take the following, where we go the original matrix multiplied by its transpose, multiplied by itself, by the query, is equal to those results. That's just stringing the math together, okay? And what we have in here, so this was our original set of results, and this was our new query. Okay, so but we can put this all together, and so it's like one big set of operations, and we get our results. That's basically what we have. What we're doing with relevance models. So if this is what we're doing with relevance models, what's interesting is we can actually tear this apart a little bit and see some different stuff in it. So let's go ahead. C transposes C, C, and Q. All right. Now, what are some of the interesting things that we have here? If you take this inside portion, if you take the document word matrix, the transpose multiplied by itself, you'll get out of it a vocabulary by vocabulary, basically a notion of vocabulary similarities. So we'll get out of it this word, this vocabulary item is similar to this other vocabulary word. Okay, that's what this basically produces for us. And so if you go back in the history of information retrieval, you'll see lots of techniques where people will be like, what I want to do to sort of expand my query is I want to be able to use word-to-word similarity. Okay, that's cool. And so they would use word-to-word similarity, and they effectively stick that in to modify the original matrix. Okay, and then they run the query. Pretty cool. Alternatively, you could actually, and you'll see that there are other people who've worked on techniques that produce a document by document matrix, which are basically document similarities. So how similar is this document to this other document? With the notion being that when you've got that new matrix, this document by document matrix, then we can go, we'll multiply it by C. We've produced a new matrix where we've used how similar we think documents are to each other, and then we can run the query against it. So bear with me here. So we said that this is basically relevance models, right? It turns out that also techniques where people are, oh, I want to use vocabulary similarities. Relevance models is basically, I'm taking use of vocabulary similarities. Or relevance models is like, oh yeah, I want to take document similarities and use it to modify the notion of what retrieval is. So you could either view it as using vocabulary similarity or document similarity, or of course you can view it as, well, the setup that we had, which was, yes, first we're going to do the retrieval, all right, and get the document scores, then we're going to multiply to get a new query, and then we're going to run that against that. They're all interrelated. They're all basically the same sort of thing, just done in different ways, and some of them have been more successful than others. All right, we can continue this, by the way, though. If we were to look at this part, the first three of them, this basically gives us a document by vocabulary. This is then what we would view as producing a document expansion. So this is the result of doing this first part. All right. So the idea is I want to expand my documents. I want to give additional probabilities to the documents. We were talking about adding additional probabilities to the query, but you could view it as we're actually giving additional probabilities to the documents because that's what's being done there. Likewise, if you take this portion, the idea is that you do a v by 1 expanded query. So, all right, do I want to expand the documents or do I want to expand the queries? Do I want to use vocabulary similarities, document similarities, whatever? You will go through the history of IR and you'll see all these sorts of different techniques, but they're all basically part of the same setup. Okay. So let me write this out in words for everyone. Thus, approaches that use word-to-word similarities to improve information retrieval are doing the same, I'll put it in double quotes because it's not exactly the same, but the idea is the same thing as using document to document similarities, or because this is all related back to blind feedback and relevance models, they're all basically the same sort of thing. All related to each other. Okay. Turns out that as I was studying this stuff, this is the formulation that I came up with for this way of understanding it. Turns out that Fernando Diaz at the same time, or before me, but I was not aware that he was doing it before me. So I wasn't aware of what Fernando was doing until I saw it and said, oh, that's the same sort of thing that I was doing. But this formulation is formulation I put together. His formulation, you should see it if you really want to see the details of proper math, proper explanations, a whole body of excellent work that Fernando did on this. You see is basically, you can see his PhD thesis, but you could also see his paper regularizing query-based retrieval scores. And this was in Information Retrieval Journal back in 2007. And so Fernando has it might be the same, maybe I'm wrong, but has a similar breakdown, a similar explanation, but it's all mathematically clean and pure. I'm just sort of hand waving here, okay? And I highly recommend that. Excellent work. All right. So, yeah. But this tends to be the case. So while things are all interrelated, it still matters how we really actually do them, all right? And that's one of the great things about information retrieval is that we come back to always empirical results. So all these methods over the years, yeah, we run them on our test collections. We try them out and we see are they actually better or not than other methods. They might be interrelated. We might say they have something similar to each other, but what really comes down to it is that some techniques do work better than other techniques. All right.